All right. Good morning, everyone. My name is Andrew Rangel. I work at VML. It's a marketing agency out of Kansas City. This is my first time speaking, so hopefully I do a good job. I am an iOS developer by trade, and I recently got started in computer vision. So I wanted to give this talk as someone who's been into it about 3-4 months. So still a beginner, and fresh in my mind is all the difficulties and kind of beginner things you run into within computer vision. So I am by no means an expert, but I at least know enough to give you a high-level idea of what computer vision is and how you can get started. So, when people start out thinking about computer visions, the first question is, how do computers actually see? A lot of people think it's something like this, Terminator vision, processing information. For some reason, it's got the red tint. Not quite. Other people may recognize something more like this. You may have seen images from self-driving cars, or facial recognition, or people tracking. And this is not actually how the computer is processing information. It's actually more like this. Now, if you squint your eyes, you may recognize the amygdala logo in there. And this is a data representation of a grayscale image, and this is how the computer actually processes what it sees. And if we zoom in, we can see that each pixel is represented by its grayscale value. This is a black and white picture. 255 is white, 0 is black. So you can actually, if you format it correctly, you can see what the computer is seeing. And what it does is it takes this matrix of information, of pixel data, and it 99% of the time is going to process it at grayscale, because the color adds extra layers to the matrix that usually aren't useful unless you're trying to understand color information about the picture. So a lot of times if you see like Tesla's equipment, their cameras in their vehicles are just black and white grayscale cameras, so they don't have to go through this extra step of processing. So the really interesting part of computer vision is it's really all just matrix math. You have values coming in by the grayscale data from the images, and there's just mathematical functions on the matrix that creates all these exciting things within computer vision. It really kind of opened my mind, and I put a joke in here, seeing the matrix. It's like seeing the data flowing by, understanding that really all we're doing is using old, well-established mathematical formulas on this information to process images. Even if you think about if you've ever used any photo editing software, done something like a blur, what it does is it takes the information about the pixels and it takes an average of these values and replaces these values, which blurs the lines. So computer vision is something that people may not realize that they're actually somewhat familiar with in terms of the processing of images. But then there's kind of the next step of what you do with it. It's like, okay, I have my matrix, I kind of understand what the computer's working with, but how do I do the computer vision part of it, not just image processing? So one of the main tools is OpenCV, CV standing for computer vision. This is no walk in the park to deal with in terms of installing it on your computer. I will gladly admit that it took me a day and a half to get it fully implemented. They don't make it easy. There's not really a Docker container for it yet. So as you're looking into this, just note that I'm going to try to throw these slides up somewhere, but I've included a link of what I used to install it on my Mac. And then I use OpenCV primarily with Python. So if you have these two things, you can actually do a lot within computer vision with a relatively small amount of code. So let's say we have OpenCV, we have Python, we're all set up. What's step one? You want to start with your image source. Here I grabbed an image of the stadium, and as you can see, this is the entire code to work with this image. You see you're just importing CV2, and you just say image read. And so the great thing is once you're set up with this, it's fairly easy to work with. And what this does is this read takes this information and turns it into a matrix, and they call it a mat file. Mat for matrix. Step two, convert it to grayscale. As you see the dramatic change in the code, simply just adding a 0 here means grayscale. So far this is pretty easy. We've got the image, we've got it converted to grayscale. It's in a mat file, we're ready to go. So then step 3 is you need to process your image. So what you're doing is you're handing the algorithms these images and these files. And in the normal format, it can have a hard time of reading this information. So what you can do is use different ways of processing your image that make it easier for the algorithms to understand what it's seeing. So as you can see here, there's what is called thresholding. And what it does is, if you can remember, this is grayscale. It picks this 127, this value, everything below it is white, and everything above it is black. So 0 to 127 white, or the opposite, 0 to 127 black, 127 to 255 white. And what that does is you can imagine that it gives the algorithms an easier time of picking out details. Because if you can imagine, what it's trying to do is recognize patterns in the data. And so a huge part of computer vision is actually this step. You get your image, and this could be a still image or video, and then you process it to say, if I'm trying to do OCR, which is reading text, it may be better to have crisp black lines and kind of just wash everything out. If I'm trying to do landmark detection and see patterns and maybe recognize that this is a stadium, truncation may be the best way to do that. And this is where a lot of people get hung up, because once you get into this step, now you're getting into the mathematics. And a lot of the how-to guides tend to forget that a lot of people, aren't PhDs when it comes to these algorithms, and they're like, oh, well, you should just, use thresholding, or, I think binary inverse would be better than this. And this is also kind of the value you can bring as a developer or a non-developer, kind of understanding step 1 through 3, getting it set up, how a computer is processing information, and then understanding what it takes to modify the image to make it easier to recognize. Now, step 4. Really, up until now, what we've been talking about is more image processing. This step is what makes it computer vision. So what you would be using is artificial intelligence and machine learning to create powerful products or apps. And in regards to machine learning and artificial intelligence, machine learning is just taking one of these frameworks or algorithms and running it through a lot of images to get it to train to recognize. And then your app's ability to take that information and do meaningful things with it is considered artificial intelligence. So don't let those terms scare you, because computer vision is kind of difficult enough when you're just kind of searching around. Once you get into machine learning and artificial intelligence, it's kind of mind-blowing when some people discuss it. So these are kind of the things I'm going to cover. Definitely OpenCV, but also, and really OpenCV is used with a lot of these in conjunction for the initial getting the image and processing it. TensorFlow is a Google product, and it's often coupled with an Inception framework. And Inception is a generalized trained model for recognition. And so for this, if you had an idea of, I want to make an app for Boy Scouts to recognize spiders or planes, one good thing you could do is use TensorFlow, and they have some great example projects where you can, once you get through the, again, probably day and a half setup, on their README it says, if you've gotten to this step, congratulations. So don't be intimidated if you have a hard time getting these things installed. They do have a Docker container though, so I should have probably chose that step. Once you get their project set up though, they have some great walkthroughs to where you can just hand it pictures of spiders and just hit run, and your computer will train and the algorithm will start recognizing it. This is something that's very CPU or GPU heavy, so this would be for someone who has probably one of the newer laptops, or hopefully a Windows computer with an NVIDIA GPU, because they have special hooks for things like CUDA cores and stuff, if you have those. Now, if you don't have a super powerful computer or you just want to test it out, the good thing is Google has a Vision API, Microsoft has one, and Amazon, and I'll kind of discuss those.
One question. So the TensorFlow, is it completely local to the server, I mean to the PC you're running on?
Yep. Yeah, it's not an API.
It doesn't phone to some other service.
Yeah, so it's offline. So as a mobile developer, I was actually dreading getting this set up in mobile because it's so difficult on my computer. But in mobile, it's actually super, super easy. If you're an iOS development, you actually can just use a CocoaPod, and so it takes almost no effort. And they've built an OpenCV Android SDK. And also, mobile is a natural fit because you have a device with a camera. So you have all of those hooks into the camera already, and it's fairly trivial to throw an app together. I actually put this app together in 3 days from idea to having it published in the App Store, just to kind of try it out. And I was using the Inception network, and it is hilariously bad at recognizing objects because it's such a generalized model that it has a list of labels, and it can only pull from that list. And so here it thinks a globe is a crash helmet, and it's actually fairly certain that it is a crash helmet. Often it'll recognize hands as band-aids and feet as remotes, and it's hilarious. Not to dog on computer vision too much, but it's funny in a constrained environment how bad it does. But this also is a real good way to realize that there's a challenge, and when there's a challenge, there's an opportunity, in that using a generalized model for trying to identify, it's going to do a bad job. But with your ideas or things you want to investigate, now you have an opportunity to create a custom trained model that will do a really good job of identifying what your idea is in. And so I think there's definitely a lot of growth in this industry, and despite the big names saying, Apple, Microsoft, Google, everyone, they're doing computer vision or augmented reality, really they're just building the tools for developers to create specific products. I'll pause for a second to talk about myself. I have an unconventional background, which I wanted to mention in this. I actually started life as an IT recruiter, so I was much loved by the developer community, which is a joke. And I fell in love with programming, and I realized that development is just a skill that you learn. You don't need to be a wizard or a guru. And so about 4.5 years ago, I started in mobile development, and I've had the opportunity to work in the IBM Apple partnership, working directly with Apple. I work at a global ad agency now, working with Fortune 100 companies. So if you're thinking about getting into development or you're just starting out, definitely don't be threatened by all the information or all the kind of bias that's out there. And this happened to me again looking into computer vision, because there are a lot of mathematical aspects, and that's something that I don't have a strong background in. But really, if you put hard work into it, you ask a lot of questions, and you have an open mind, you can get into this stuff fairly easy. And I mention this because computer vision is a little daunting to get started, but once you understand the core concepts, you can get an app out there, or you can start a project. So now I want to kind of go over the wide world of computer vision. Everyone's getting into it, super popular. The good thing is, any of these platforms and more, you can get into it. There are setups and distributions for things like TensorFlow for every platform. A lot of people like using even the Raspberry Pi because it's easy to hook a camera up to it. I've seen projects where they put one near the coffee machine and it says, is there someone at the coffee machine right now? And rather than having to look at the video stream, it just recognizes that there's a person in the frame, and it'll have a light set up to where it'll be green or red. Green, coffee pot's open, go to it. Red, it's busy. So there's a lot of cool little projects like that. And really what you're doing is you're training your model on a powerful computer and then distributing it onto these. So for like my mobile app, it's actually not very CPU heavy because it has the model packaged into it already. And so all it has to do is run against that. And really what it's doing is it's saying, here's this matrix of information, try and recognize what you see in here against the model. So once you've done the hard work of training, it's very smooth from then on out. When you go into this stuff, you're going to see a lot of crazy things. Hog detectors, SLAM, CNN's not a news network, GAN, structure from motion. I actually asked the computer vision subreddit, I'm given a talk about computer vision, what should I talk about? And these were the suggestions. And so when you're looking into this field, don't get intimidated by these things. This is a lot of the math that they're going to throw at you, convolutional neural networks. Basically, a neural network is, let's say I trained my app to identify spiders, and then I can train a separate one to identify plants. What I can do is I can put those in a neural network where first it tries to identify a spider, then it tries to identify it as a plant, and it goes through. So you can actually take a bunch of things together, and it can more generally identify objects. So just to kind of throw it out there, if you see stuff like this, just kind of graze over it, and don't let it slow you down. So with TensorFlow and Inception, there's a C++ route, there's a Python route. I highly suggest Python. It's very easy, but if you're a C++ developer, that's kind of the base, and Python ports everything to C++. So here's kind of an example. I have a picture. I want to identify it. It's 89% positive that this is a giant panda. Wow, that's great. Look at the power here. I'm not sure what an Earth star is, but luckily it's not very confident that that's it. And so this is kind of the example that they give you, and it's kind of scary. It's like, man, right off the bat, it already knows, it's so good at identifying this stuff. And then you say, okay, well, I want to try my own thing. So here, it's a little bit confident that we're looking at a seashore, which is not the case. Even domes and palace are just completely off. And when I saw this, I kind of got downtrodden a little bit. I was like, wow, maybe computer vision isn't as good as I thought it was. I don't know if it's ready for prime time. I did realize after a while, if you squint a little bit, the green in the background, maybe that's the ocean and it thinks it's the sand. I'm not sure, but this is kind of a good example of really here's where your value comes in, is seeing opportunities like that and then training apps or modules so you can identify these things. So again, a lot of great opportunity to create your own applications. So let's say you just kind of want to test it out. You can kind of go through APIs and it's fairly easy. I ran this through Google's Vision API, and it's actually so simple to set up. They have an API Explorer, so you just put your image in there and sign into Google and you can just run it, so you don't actually have to write any code. And you get a JSON response back like this: metropolitan area, aerial photography, bird's eye view. It's pretty good. All of them are in the upper 90s. So it's kind of a good way to say, I've got an idea, let me throw it against something like Google's Vision API and just see what that can do. And maybe I can just use that API in my app and not have to train my own algorithm. Here's landmark detection. I tried every landmark in Nebraska. It didn't recognize any of them. So I went back to Kansas City, and this is the only one it got, which is Union Station, and it's not even that confident. I'm fairly impressed because it's lit up blue right now, but still, landmark detection, it's not that strong yet from Google's standpoint. They show a really awesome demo where they take a picture of the Eiffel Tower in Las Vegas, and it knows it's the one in Las Vegas, not in Paris. But apparently you have to be in a pretty big city for it to really nail the landmark detection, which is unfortunate. Text detection, same thing as OCR. I thought this was really cool. I want to take a picture of a sign, and I just want to know what it says without typing it out. This stuff's hard to read. It's a fairly high success rate. Some of it's not good. There's some misspellings, some missing letters. And the format it gives you in is a little bit difficult. So you would still have to go in and fix the errors, process the formatting, and then also make sure it's the right word, because I noticed sometimes it'll actually replace it with a different word entirely. But still, the technology is getting there to where it can do a lot of the heavy lifting for you. You tweak it a little bit, and then it can do a really good job. And this is actually the code for using the SDK from Google Cloud Vision in Python, and it's super easy, and it's actually super short because everything from here down is just printing things out. So all you need to do is call the client and pass your image. They do some interesting stuff with the auth, where you can actually use your Google account as authentication, so you don't have to work with tokens or API secrets or things like that. So I would recommend this as if I want to get started, I want to write some code, so maybe I can pull in the camera source against this, or I just want to pass it my own images without being in the API console. This would probably be the best way to get started. Because with TensorFlow or OpenCV, there's a lot of work you have to do to get going. There's also the Microsoft Azure Computer Vision. It's specific to Azure because what you're actually doing is you're running it on an Azure instance. This was a little bit more difficult for me to get set up. You have to sign in for a Microsoft account, set up an Azure service, give them your credit card, and then they promise not to charge you unless you get crazy with it. I ran it against the visual features, not as good as the Google Vision API. It did get outdoor sports field though, which I thought was pretty good, and it's a fairly high percentage. So I thought that was a little bit more specific than the Google Vision API, so you can kind of see the difference here of, well, if one service doesn't work for me, I can try another one, and maybe for my purpose, like for instance, if I'm doing something where people can take pictures and it'll recognize if you're at a sports field or a stadium, this would be a good fit. So again, a way to kind of check out other services before you have to go through and say, okay, I have to train my own model. For landmarks, it didn't get this. If you'll notice, the landmarks array is empty, and it just recognizes it as a building, and it's not even quite certain that it's outdoor. So not really a good fit from that standpoint. From an OCR standpoint, it was actually interesting. It was a huge pain to handle because their JSON response is actually each individual word or character that it recognizes. So you have to enumerate over this complex JSON structure and then append all the strings together. And then if you notice, there's some crazy symbols in here. And it didn't do nearly as good of a job as Google. So really what I think this helps you with is kind of going through the services and starting to think, like someone who knows computer vision and can kind of critique it and maybe try to understand, maybe if I process this image differently or I ran some thresholding with OpenCV against it, then I can check it with Microsoft again, and then maybe it does a better job. Again, small things you can do before you have to train your own model. Here's the code for it. This is in .NET using its API. It's a little bit more verbose, but still not a huge pain. And when I thought computer vision, I was expecting, all sorts of things you have to do, even with an API in terms of processing. But here, it does all the work for you, and you just have to handle the response in your own way. Amazon recognition. I hate the way that they spelled this. I have no idea what they're trying to accomplish, but that indeed is what it's called. They have an object and scene detection. This was pretty good if, let's say you were trying to process a lot of information. Let's say you scraped Google Images and you wanted to get pictures that were of an aerial view. So you could build an app that just pulls in random aerial views for people to look in, or creating like a screensaver that has different shots, kind of like an Apple TV. What you could do is set this up on Amazon Web Services, and they'll actually run, and it's very cheap to go over a lot of images, categorize them, and then you can say, okay, well, if aerial view, if the percentage is over a certain amount, let's say 95 or even 98, go ahead and save that image, and then you can create kind of your array of images for all aerial views. So that's something I thought this was really powerful for, is just going through and processing a lot of images. And even on their website they say, process millions of images. That's kind of an instance of where you'd want to do that. So with computer vision, you're really standing on the shoulders of giants, and you shouldn't feel bad about that. Don't feel like you need to fully comprehend everything from the development or matrix or the mathematical functions. You can kind of understand what computer vision is and start to generate some ideas in your head, or even recognize when people are using it. And a lot of times going into things, they'll try to explain the math, or they'll say, well, first you need to understand these things. Not really. You can get started with the API and get going without too much of an understanding, and you shouldn't feel like a charlatan or anything like that. One thing I learned, you really have to focus on a project. I searched for cool projects for OpenCV, and there are thousands and thousands of blog posts and listicles and things like that. And it's something where if you kind of just get into the technology, you kind of stump yourself and say, well, I don't really know what to do, and I don't know what technology to choose, I don't know how much understanding I need. What I've learned that if you just come up with a project, it's a lot easier than to work backwards from that and say, I can use the API, I need to train my own model, I'm ready to start a business on this, I could be a millionaire kind of things. And then really just explore your options. Maybe you don't have to do a ton of work to get yourself off the ground. One thing I used is there's a course on Udemy, which they just do a lot of teaching online, and they often have sales. So for $10, I got this huge mastering computer vision and Python course, and they really hold your hand through it so you can understand it even better. So you can kind of take a generalized view from this talk and then learn even more, and you kind of have a better context in terms of domain knowledge that they're talking about when you hear Matrix or OpenCV or things like that. And then really just taking the leap. I have been interested in this for a long time. Thought AR was cool, and I was thinking of all these different cool things I could do, and I dragged my feet for a long time, just thinking, oh, it's so complicated. I almost gave up when I was trying to install OpenCV because it took me over a day. And I was just like, well, maybe I just don't know enough to get started with this. But I powered through it. I used course and other guides, and you can get going pretty quickly. And once you kind of go over that hump, you can speak intelligently about it and start thinking about projects. So I work at VML. Some instances of computer vision in real life is this is called Mobile Medic, and I thought this was really cool. It's in Australia, and they have like an army medic corps, and I guess it's very hard to get into. It's very prestigious, and so they had these signs up like at a bus stop or something like that, and you take the app, and the app will use computer vision to recognize what image you're looking at, and then it'll initiate a game that is actually trying to diagnose what's wrong with this person. And so you'd hold it up, as you can see, and you'd see like an x-ray, and as you move the camera, the x-ray would move up and down, so it's almost like you were x-raying the person. And what's that doing is, with what augmented reality does, is it takes computer vision and it will actually lock the position of the image. So there's subtle things in these images that the human eye can't see very well, but the algorithm does. And so it knows where you're at in 3D space, and it'll overlay things over that 3D space. So augmented reality is just computer vision plus positioning, and then some kind of visual entity or engine. So a lot of people use Unity or other gaming platforms to create the graphics, especially because a lot of times they're 3D graphics. But this allowed you to take the test, so to speak, and I thought it was pretty crazy because if you passed with a certain score, they actually called you and said, you've won a scholarship to the medics, and people were getting jobs on the spot. So kind of an interesting use, and as you can kind of see, a lot of times computer vision is used in a very subtle way. This is another one that's becoming a big field, is emotional intelligence and recognizing how you're feeling from facial recognition. And this is an industry that started in academia and has grown a lot, and they're learning by using facial recognition And I chose this screenshot because this is really what it's doing, is it's recognizing different patterns in the data to tell a human face, and then also once it maps your face, it can look at the subtle movements of like your lips if you smile or if you frown. And this app is for Bentley, and they show you videos of random stuff, and depending on how you feel, they customize your Bentley, and so they decide whether you want leather or cloth or red or blue. So it's that half of it is kind of ridiculous, but I guess if you're shopping for a Bentley, it's cooler than answering a survey. But this is kind of the ways that this technology is going to start sneaking into stuff. And really, to a lot of people, it feels like magic, and even to me, that it's able to do these things. But when you understand what it's doing, it's very simple. And really, it's about the training aspect that gives it its magic.
Would be interesting how it's going to work with the different cultures.
Yeah, well, that's one thing is, if you look backwards, we've had the technology for this for a very long time. You actually do not need a very high resolution image. You're porting it to grayscale anyways, and it's looking for patterns, which means unless you're trying to do something very fine like OCR, you can use a very small image. And a lot of times, OpenCV will scale the image down first so it has a smaller matrix to deal with. Really, what's made it more popular now is all the pre-work that's been done in training models and understanding how to train models. One thing that's crazy, and you may hear stuff like this with artificial intelligence, is they're not 100% sure how it works and why it works the way it does, because what they do is they create the neural network, so you're stacking all these models together, and they feed it random information. They also go through and kill certain nodes randomly to just throw those things away. And then they took from nature that if they go through and put random zeros places, it makes it more accurate. And I watched a talk recently from Google, and they're like, I honestly can't tell you why it works so well, but it does, so we're going with it. So that's why people are like, oh man, scientists and developers don't even know how artificial intelligence works. And it's really just that kind of learning that's happened that's really made it popular now. So I feel like this is a good tipping point to kind of get into this technology. I want to give some special thanks. David Mitchell and Heather Downing at VML helped me out, convinced me to do this talk. Some users on the subreddit gave me some good information. That's another thing. There's a lot of resources out there. Things like Reddit, Twitter, online guides, online courses, where you can reach out to people, and a lot of people, especially in this field, are pretty excited about it because it's an exciting time, so they feel free to help you out, answer your questions, and things like that. So this is one of the more inviting communities that I found for a newbie. I've also, again, I'll try to figure out if they have a way of letting everyone know where I post these slides, but I have some links to getting started with OpenCV and the course. Installing OpenCV, I just did it for my Mac, but there are other sources for Windows and Linux. And then I would, if you're interested in this at all, I would definitely check out this computer vision course. If you go to Udemy.com and just search for computer vision, it's one of the main ones that pops up. And the secret to Udemy is almost always they're having a sale for $10. So they're like, this course is $300. I wouldn't pay full price for it. Just wait for there to be a sale, and you can actually get it for pretty cheap. And then here's some more information about some of the more complicated stuff. And it looks like I have a decent chunk of time, and I was going to show you. So what I have here, I'll just kind of breeze through this, is an example of how easy it is to kind of get started with these things. This is some sample code using OpenCV. that will actually do something very similar to Snapchat, where you do face filters. So that's one of the things that's super popular right now. A lot of companies are getting into it. And it's interesting because the code's not that difficult. A lot of this stuff is well established. And really what it's doing is it's defining landmarks on your face and then on the face of the image, and it's taking that image and just setting it on top of your face. And just like I mentioned before, it's tracking where your face is moving and then moving the image. So, you know, what Snapchat does is an order of magnitude more than that to make it work very well. And then they also do things with voice and things like that. But it's actually fairly straightforward to get it going. And then here's an example of where you can just pick any image. I found a picture of Abraham Lincoln online and just give it a shot to see if you can make a filter from it. So I will attempt to run this now. And what it's going to do, if it works, is it's going to map Abraham Lincoln's face to my face, and if I take off my glasses, it may work a little bit better. But as you can see, it's kind of spooky, not very good. The lips don't move because his lips are closed in the picture, and then the frame rate is really slow. But with a minimal amount of effort, you can get started in this and really get going with things like, you know, face filters, object tracking, all kinds of fun stuff. So the good thing is a lot of these things are established and not as difficult as you would expect. And that's the end. I can answer any questions if anyone has any.